Okay, hello everyone. Yeah, I guess thank you for the introduction, Rens. So I'm gonna talk today about how you can make stylable custom components in SwiftUI. I guess I'm gonna start a bit by telling about myself. So I'm Eskil. It's a Norwegian name. Um, you can pronounce my name by speaking out SQL. It's actually kind of weird because usually when someone talks about SQL in the office, I instinctively sort of turn my head because it sounds like they're saying my name. And in fact, also nowadays with the AI meeting notes, if you've tried that out, sometimes if someone says my name, it gets confused because it thinks someone's talking about the relational database, which is kind of fun. Yeah, I joined Q42 this year. Quite happy to be part of the nerds. Yeah, I've been working with Apple technologies for quite a while. I launched my first app in 2017. And I currently have 5 apps in the App Store. So one of the ones I think I have the most fun working on is this one. It's Ditherables. It's like a graphics app where you can try out different palettes on your images. It's quite popular with pixel artists and designers and that sort. Yeah. Now in this app, probably like many of your apps, I use a lot of custom components, and well, that's what I'm going to speak about today: is how you can make those components stylable in SwiftUI. So one of the reasons why we love SwiftUI is because it gives us this expressive syntax that allows for readable, maintainable code with very few lines of code, actually. And one of the things that makes, well, some of the times we make custom components ourselves, and then we kind of sometimes forget how expressive SwiftUI can be by itself. For example, with styles here, we often add like enums and do all kinds of stuff like that. But one of the things that are often forgotten is how to do this the SwiftUI way, how we can make idiomatic SwiftUI components. And by that I mean, how can we make components that are natural to all developers that have just seen a little bit of SwiftUI, that they all can read it and understand it, that you don't have to explain to them how the API works. Now, one of the most powerful things in SwiftUI is this idea of separating logic from looks. And you do that with view styles. So you have button styles, toggle styles, picker styles, all kinds of things. Usually looks like this. You add like a button style. And SwiftUI comes with a lot of built-in button styles. You have primary, for example, bordered, border filled. You can also make your own. And here again, you see there's no logic in here. It's only styles. And that's a very great abstraction. Now, of course, you have the primitive button style where you can sort of do the logic yourself. But the main idea is separating logic from looks. And one of the best examples of this is the pickers. So this is how the picker looks like, and it also has the picker style. And SwiftUI comes with a couple of built-in picker styles. So these are the ones that are available for iOS. And just to show you how, like, the whole idea here, I'm gonna go through all of them. So the automatic is you most commonly see it as a menu or a wheel on iOS. It's based on the platform or the context you use it in. You also have inline. If you use that in a list, it will give you this inline picker. Menu, we have all seen this. Now there's also this cool one, navigation link. When you click it, it opens a new, it does a push in a navigation stack. And notice all of these, they all behave the same way. So the logic is the same, they're just styled differently. Palette. This one is in a, if you put this in a menu, it will give you sort of an inline picker. Segmented controls. And of course the infamous wheel. Now, let's say I want to make a custom picker style. Let's say I want to make something, I have a really cool fancy app, and I want to make like a fan picker. How would I do this? Well, I want a custom picker style. Now, you can try to sort of make a struct and conform it to picker style, and Xcode will say, well, you need to fill in these methods. But this looks a bit strange, right? Because first of all, these are static, which means, yeah, you can't really have instance variables. And it's also using these sort of undocumented, private-looking types that are internal to SwiftUI. And furthermore, the Swift compiler emits a diagnostic because it can't really resolve the generic types. Now, this is clearly not the way to go. And I think, I don't know why, but Apple doesn't want us to make custom picker styles, or maybe they didn't implement it. But one thing we can do is we can make our own components. So let's make a custom picker. Now, picker is already reserved. I'm going to call mine radio group. Now let's look at what we already have. So this API looks pretty good. It's expressive, it's declarative. So I want something like this. This would be great. Radio group with radio group style fan. Now I would start by defining the interface. I'd have a selection and content. I removed the title key for simplicity here. Now, how would the body look like? Let's again look at what we want. So I'll try to decompose this into two parts. We have the cell, which is clickable and shows the selected state. And then you have the body, which lays out the different cells. Let's give these some tokens so we can speak about them more abstractly. Now, the body should ideally look something like this. You have the body that lays out the cells, and the cells should then come from for each that we defined here. So ideally, we want our component to produce an output like this. You have the body, and then it wraps around the for each, and then all the subviews in the for each should be wrapped in a cell. Now, you might have tried to do something like this and realized it's not that easy, actually. Even though it happens all around in SwiftUI, this was not really, there was no public API to do this until iOS 18, when Apple introduced the subview APIs, or they sometimes call it the container APIs. So one of these APIs is this group subviews. It takes a view, content, and it gives a collection of subviews. Now, subviews collection is very similar, but not quite the same as what you have in a layout. In a layout, you have the layout subviews, and it's basically a collection of identifiable views. Now, what's great here is you have access to container values. So you can. It's also kind of a similar concept in layouts. You have layout values. In container values, you can define your own data properties, but you also have access to the views tag. Now, another thing that's quite interesting to look at is the number of resolved subviews that you get from this API. So for each, you'll have the number of entries in the data that you provide will be the resolved subviews most of the time. Now, in a VStack, it works in a cumulative way. So if you have two texts, for example, it will be 2. If you have 2 texts and a for each, you will have 2 plus the number of entries in the for each. A text is always 1, even if you provide an empty string, still 1. And a very interesting case is the empty view, which has 0 resolved subviews, which kind of explains this behavior. When you put an empty view in a VStack, for example, it won't add additional spacing between different views. So this is what we have. But remember, our original goal is to sort of provide a way to style this. So we need to get the body and the cells from a style. I'll start by defining a protocol very similar to how the button style protocol looks like. So I have a method to make the body, to lay out the cells, and a method to make the cells. Now these both take a configuration. So for the body configuration, I have a cell group, which is basically a view. And the cell will have a view and also a flag indicating whether or not it is the selected cell. A very simple style we can make is one that just puts them on a row and makes the selected cell bold. Now let's look at how this will be used in the radio group. I'm going to add a radio group style environment value. I'm using here the new entry macro, which is quite nice. Produces a lot of boilerplate, and I'm adding a helper method on view. Now you'll notice I need to sort of type erase the group style, the radio group style, in order to sort of be able to have multiple different kinds of styles. And that looks something like this. It's basically just wrapping the produced views in any views. I'm going to add this to the radio group. And I'm going to go from this to this. So I start by taking making the body from the group style, and it takes the view produced below with the for each. Now, because I have access to container values, I can find the tag like this to determine which cell is the selected one, and use that to produce the cells. Now, because these cells need to be clickable, I need to wrap it in a button. And I set the selected on click. And this is what it looks like. So now we have a stylable custom picker. Now, let's look at how I would make the fan, quite briefly. Start by making a new radio group style. Let's start with looking at the cell. I've defined the cell like this, and you notice how clean this actually is. At a glance, you can see how the style looks like, and there's no logic in here. It's all abstracted away. The only thing you need to worry about is whether or not the cell is selected or not. Now for the layout itself, I again used the group subviews API to sort of figure out how to lay out the cells. And then I've hidden some logic that you don't really need to care about. It's quite long, quite intricate. But the whole idea here is that this only contains the layout, and everything else is abstracted away. And this is what we have. Now, I could end my exploration here, but I think we can do it better. So let's look at some improvements that can be done. Now, first of all, I see two low-hanging fruits. We have a couple of places where we use AnyView. And we also have a quite high deployment target now of iOS 18. Now, there's also, since this is a plain protocol that I've used, there's no real way to access the SwiftUI lifecycle properties through state or environment. And that's a quite tricky problem to solve, but I'll share some workarounds for that as well. Now let's start by tackling the use of AnyView. So the main issue with AnyView is that it makes it more difficult for SwiftUI to find the difference between two views. This can lead to performance problems, problems with animations, or other issues. It's also quite difficult to sort of find, like, if this causes an issue later in the development cycle, it's not quite easy to figure out what's actually causing the problem. And so a lot of developers are quite scared to use it in production. There are, however, alternatives. So let's look at how we can remove the use of AnyView. So AnyView is currently used in two places. I use it in the configurations, and also I use it to erase the radio group style. in the environment. So let's start with the configurations. Any view is used to erase the views. Now, when I'm tackling these kinds of problems, I usually look around me because there's a lot of clever people in this world that are facing the same issues. And in fact, Apple's also faced this issue when they made the button style and the toggle style and the picker style. So let's have a look at what they've done. If you look at the Swift interface for SwiftUI, you'll see this with the comment, a type erased label of a button. And they've made sort of a view with a body of type never, which is quite weird if you think about it. How can never be a view? But actually, because you cannot create any instances of never, due to the logical fact that if you query an empty set for anything, it will always be true. Therefore, never can actually implicitly conform to any protocol in Swift. Also view. That doesn't really help us. It's just an interesting fact. But so this is a bit confusing. Now, I looked up at a couple of open source re-implementations of SwiftUI to see what they're doing. So there's one that was made by the Swift WebAssembly team. It's called Tokamaka. It's currently archived, and they actually do it the same way I do with AnyView. Now, that's still no guarantee that it will cause any problems. So I looked at another open source re-implementation called OpenSwiftUI. And what they've done is they've looked at the disassembly of SwiftUI and looked at done runtime analysis and built all kinds of tools, inspect the graph that's made by SwiftUI to sort of re-implement it for the public. Now, it's still a work in progress, and they haven't implemented the button style, but they have toggle style. And they've done it the same way as Apple. They have like a label, but we see it conforms to view alias, which is quite interesting. So let's look at how the view alias looks like. It's also a view, and in this implementation, view has this static make view function that you might recognize from when I tried to make a custom picker style using the SwiftUI API. And in fact, all SwiftUI views have these, but they're usually hidden to us. Now, this line is quite interesting because it tries to recreate a view using something called source input of the alias type. It's still quite confusing, so I looked further in the same file that this protocol is defined. And they define this convenience method on view to set the view alias of a view. It uses something called static source writer. The static source writer writes to the SwiftUI graph indeed a source input of the alias type. This sounds interesting. So I looked again at how toggle works. It sets a view alias of the type toggle style configuration.label. I'm not sure if you see the full picture, but this is quite interesting. So let's look at what's going on. So toggle has a label, and the label gets, in the SwiftUI internal graph, it gets assigned sort of an alias or a pseudonym or a tag, or call it whatever you want, of toggle style configuration.label. Now, when you make a toggle style, you work with the toggle style configuration.label, and when SwiftUI encounters that in its view hierarchy, it can see, oh, this one belongs to the label that is part of this toggle. So it's really, yeah, I think the key here is in alias. It's really just like a name, and when SwiftUI sees it, it sort of copies over all the modifiers you've attached to it to the actual label. It's a pretty brilliant and elegant way to do type erasure. Still, this doesn't really help us because we don't really have access to the internal SwiftUI graph and those private methods. But if you realize something, this has actually been in front of our nose the whole time, because we can indirectly use this mechanism by using the button style configuration. Now, given we already have a button to do the clicking of the cell, we can use this instead of any view. We can use button style configuration.label. Now, to access this, I'm going to make sort of a puppy implementation of a button style that just gives me back the configuration. And then looking at how I've implemented the radio group, we have the button for the cells. I'm going to refactor it a bit. So the label is just a subview again. And then I can use the button style to access the label. Now, I think this is usually good enough because you generally will have more cells. So if you have performance issues or diffing issues, these are usually the ones where you would want to avoid any view. But we can also avoid any view in the layout. I'm going to make a primitive button style since it doesn't have, by default, it doesn't have any clicking behavior. And then for the layout, for the body, I just use an empty button with the rest of the implementation in the label, and then a button style. Now, there's still one more place with any view, and that's the setting of the environment variable. Since we need to type erase this for it to work at runtime. Now, this is technically not possible or not needed because we can simply make radio group generic on the style and add it as a simple property, and then move the method under the radio group itself. Now, the disadvantage here is that you need to set this on the direct child of the radio group, just like you will with some of the image and text APIs. For example, resizable, you need to set directly on the image. It's the same thing, it's a disadvantage, but there are trade-offs. So that's the use of any view. Let's have a look at how we can make this available for older platforms. So how can we support older versions of iOS? If we look at what we have, since we're using the new Group Subviews API, it's only available in iOS 18. Luckily, we've had a similar API since the very beginning of SwiftUI. And maybe you've encountered it in the wild if you like to sort of look at these things under the hood. And the API is called the Variadic View API. Now this might look a bit scary because it has an underscore. It looks a bit private, a bit sketchy, but it is actually public. But it's just not documented. Now, one of the most likely reasons why it's public is because it's used inline in for example the VStack. So this I've just pasted from the Swift interface of SwiftUI. You can find this yourself actually. It's usually hidden in if you look in Xcode, but if you look at the Swift interface, you will indeed see Variadic View. You can find it here. It's provided in the toolchain that you can find in your Xcode installation. If you want to take a picture, this is the time. So this is what we have for iOS 18. We can do a short refactor to use Variadic View instead. And it wants a transformer, so that's a little bit more refactoring. So here's the interface. And the body, this is now just almost copy-pasted from what I have. The only thing that really needs to change is how we extract the tag from the view. There's no public API for this as I'm aware of. But luckily, there is something similar to the container values. It's called view traits. It's also more underscores. I guess you need to have a taste for the underscores. So what I do here is I define my own tag trait and my own convenience function to set it. And you can read it by using its method type on the subview itself. So this is what we have. Now this is how you would use it. Looks very similar to what we have, but you need to use the radio group tag instead of the normal tag. Now, if you want to use this in production, you might want to use variated view for the old versions of iOS and the new subviews API in iOS 18 and newer. Then you can abstract this behind the protocol. So you can use container values and view traits next to each other. If you want to use this in production, it's a different question. Now, lastly, before wrapping up, let's tackle the missing way of state and environment. So there's not really an easy way to tackle this. I think what Apple's doing with their button styles is that they're using a modifier, and then they're probably doing some internal things with the graph as well, like you saw with the static source writer and those kinds of things. Now, what you could do in a lot of cases is just make a view and return that in the protocol. You can also use the style configuration that you defined for the cell or for the body and add parameters there if you want to have data flow downstream. You can also use container values to make data flow upstream into the parent, and you can also use preferences if you want it to travel even higher up in the hierarchy. Now, to conclude, we've seen how you can use the subview APIs to make custom components. If you're missing the ability to style a component that's usually default or provided by SwiftUI, you can make your own component look very similar by using the subviews API. You can use button styles or other kinds of view style configuration alias types for type erasure. And for older versions of iOS, a very similar analog to the subviews API is the variadic view APIs. Now, we can always discuss if this is really good to use in production. I think it's really fun to look at how SwiftUI works under the hood. I think definitely the subviews API is something that's public and available and allows you to make more idiomatic SwiftUI components. Type erasure with button style configuration. If you already have a button, go for it. If not, maybe justify to your colleagues why it's fine to use any view. For variadic view, I think if you have an app that's not critical, go for it. It is public API. Apple can't tell if you're using this in a VStack or if you're using it in your own components. But it might be less understandable for your colleagues or for yourself if you're looking at it a year later. So yeah, that's it from me. Thank you.
Thank you very much for your presentation. Do you have time for maybe a few questions?
Please, if there are questions, I'm happy.
There are any.
Did you use them in an app, this style?
So I've used part of this in different apps. So usually the problems we face is that iOS 18 is still a little too young to use as a deployment target. And then you still kind of don't want to use variadic view in production, so you end up with going back to sort of these less idiomatic ways of building components. But the button style erasure I've used sometimes, yeah. So parts of it I've used in production apps.
I just tried your app. I really like it, but it should have a Commodore 64 and Amiga palette.
Noted. Thank you.
Any other question? In that case, thank you very much for the presentation, Eskil.